All right, today we're going to talk about 1.7 transformations of functions. Okay, and this could be for quadratics, cubics, square roots, anything. Okay, so let's first talk about vertical and horizontal shifts. So vertical and horizontal. Okay, we're going to let C be any positive real number. Okay, if we look at a vertical shift, so what that means is it's going up. Okay, it takes our function such as h of x equals my f of x plus c. So if you add c at the end of your equation, that means it's shifting my graph up that many units. Okay. If we're shifting down, okay, down is instead of adding the c, we are going to subtract the c. Okay. So for example, we could have like x squared plus 1. That means it's going to go up 1 unit. So now my vertex would be 0, 1. Okay. If it's minus 1, that means I shift it down 1. So now my vertex would be 0, negative 1. Okay. Horizontal. Okay. Right and left. Okay. Now to go right, so we have h of x equals f of x minus c. So it's going to be inside that parenthesis, and if you notice, it's a minus c, but it shifts it right. Okay, so anytime it's in that parenthesis, it shifts it left or right, and it's always its opposite. Okay, it always lies. So in this case, it'd be like x minus 2 squared. So that means I would shift it right 2 units. So now my vertex would be 2, 0. Okay. Now, if we're shifting it left instead of minus c, it is actually going to be plus c. Okay, so we'd have like x plus 1 squared. So this means it would go left 1 unit. So now my vertex would be negative 1, 0. Okay. All right, let's look at an example of this. All right, use the graph of f of x equals x cubed to graph each function. So what I'm going to do is I'm actually going to graph this parent function first. Okay, so we get an idea of what it looks like. Okay, so if I pick 0, okay, so if my x value is 0, if I plug 0 into x, what do I get? 0 cubed is 0. So we have the coordinate 0, 0 for both of these. I don't know why that made that. Okay, so 0, 0. Okay. So we have 0, 0 there somewhere. Okay. There we go. We have 0, 0 here. Okay. Now, if I have 1, if I plug in 1, 1 cubed is 1. So we're going to have the point 1, 1 also. Okay. Now, if I plug in 2, 2 cubed, 2 times 2 times 2 is 8. So we're going to have the point 2, 8 up here. All right, now let's go the other side of 0, 0. Negative 1. Negative 1 cubed is negative 1 times negative 1 times negative 1. Since we have an odd number, it's going to stay negative. So we have negative 1, negative 1. And then let's do negative 2. So negative 2 cubed. Negative 2 times negative 2 times negative 2 is negative 8. Okay. And now when we go to graph this, it's going to have this little squig to it. Okay. There we go. And again, we could still plug in 3 cubed would be 27. So negative 3 cubed would be negative 27. Okay. Now, as we look at example A here, okay, so we look at example A, we have x cubed minus 1. Since that's not being cubed, that minus 1 is a vertical shift. So that means our points are going to drop down 1 unit. So instead of 0, 0, since we're going down, it changes our y coordinate. So now that becomes 0, negative 1. So we're just going to take every point and drop it down 1 unit. So now 2, 8 becomes 2, 7. And negative 2, negative 8 becomes negative 2, negative 9. And draw. And there you go. Okay. Now B is a little bit different because we have an inside and we have an outside, okay? The inside is our horizontal, and that's kind of like our H and our K. And our H always lies, so it's always the opposite, so it's like -2. So that means we're gonna go left 2. And the +1 is my K, so it tells the truth, is up 1. Okay, so now we're gonna take every point and go left 2 units, up 1 unit. So 0, 0 goes left 2, up 1. So now we're at -2, 1. 1, 1, left 2, up 1. 2, 8, left 2, up 1. So 0, 9. Left 2, up 1. And left 2, up 1. Left 2, sorry, left 2, up 1, if I can count. There we go. Left 2, that should be in there. Left 2, up 1, there we go. And there's your new graph. Okay. So inside the parenthesis, always shifts it left to right, and it's always the opposite. And then the outside's the K, tells the truth, it's up or down. Okay. Reflecting. Okay. Reflecting graphs. Okay. If we're going to reflect over the x-axis, okay, so our equation is f of x is going to be negative f of x. So kind of like your C is negative or your A is negative, depending on what it is at the equal sign. Over the y-axis is when it's on the inside. So f of negative x. Okay. All right, so let's look at example 2 here. The function of the graph f of x equals x to the 4th. So this one's my original here. Okay. The other graphs are transformations of the graph of f. Write an equation for the function represented by each graph. Okay. So if you look at this, the only difference between this one, the original, and part A is that now it's opening downwards. Okay. So it's a reflection over the x, over x. And it also shifted it up 2 units. Okay. So if I want the reflection to be over the x-axis, my original equation was y equals x to the 4th. So if we want a reflection over the x, that means beginning is going to become negative. And if we're up 2, it stays on the outside and it tells the truth. So we're going to add 2. So this is now the new equation for this function here. So negative tells me it opens downwards. And then the up +2 tells me it went up 2 units. Okay. Now for the second one here, part B, it's now still opening downwards, so that's still a reflection over the x-axis, so we know it's going to be negative in the front there. Okay. Now we shift it right 3 units. Okay. Now, since we're shifting it left or right, it goes inside our parentheses. So we're going to raise to the 4th power. And since we're going right, normally that's +3. But since it's inside the parentheses, it's always opposite. So it's -3x. And this is y, or h of x. So this would be negative times the quantity of x minus 3 to the 4th power. Okay. All right, example 3, let's compare it to the square root function. So now we have a square root function. Okay, we have our negative on the outside, and when it's a negative on the outside, that means it's reflection. And this one is a reflection over the x-axis. Okay, and we have nothing else going on, so that's the only thing for part B is a reflection over the x-axis. B, my negative now is on the inside. Okay, or underneath the radical. So again, it's still a reflection, but instead of being a reflection over the x-axis, it's a reflection over the y-axis. And then part C here, we have a negative on the outside, and then we have this +2 underneath or inside the parenthesis. Okay, so the negative on the outside is that reflection over your x. And then the +2 means I'm shifting it left or right, and it's its opposite. So this one would be left 2 units. So we have a horizontal translation of left 2. All right, all the reflections or the transformations we talked about have been rigid, okay? Those are your horizontal, your vertical, and your reflections, okay? Now we're going to talk about non-rigid transformations and those that cause a distortion, okay? Those that change, okay? That's changing in my shape somehow, okay? So now if you look at it, we have g of x will equal c times f of x, okay? Now when we did it in quadratics, it was always like our a, so a x squared, something like that. We just use the letter c here, okay? Now, if we have a vertical stretch, okay, so let me go ahead and just graph this parabola for a second. So we have 1, 1, negative 1, 1, and then we have 2, 4, and negative 2, 4. Okay, so here is my parabola, my parent function. Okay, now when the number in front is greater than 1, that means we're multiplying by a number greater than 1, like 2, 3, 4, 5, 4.5, 5.5, things like that. It is going to stretch my numbers, my y values out. Okay, so if I have 1, let's just say now my problem is y equals 2x squared. We're still going to be at 0, 0. But now if I plug in 1, 1 squared is 1. 1 times 2 is 2. Negative 1 would also be 2. If I plug in 2, 2 squared is 4. 4 times 2 is 8. So it's stretching out those numbers, okay? So if c is greater than 1, it is going to be a vertical stretch. Now, if we're looking horizontally means it takes its original one and then shrinks it in, okay? So if we look at horizontal stretch and shrink, okay, your horizontal shrink is when that c is greater than 1, okay? So they're kind of opposite. For vertical, we're stretching those numbers out for the y, but for a horizontal, we're pushing that in, okay? Your original one in, so it's shrinking it horizontally, okay? Now for a vertical shrink, okay, excuse me, for a vertical shrink, your C, your C is going to be in between 0 and 1. So like if I have y equals 1/2 x squared, okay, we're still at 0, 0, but now if I plug in 1, 1 squared is 1, a half of 1 is a half, so it's here. If I plug in 2, 2 squared is 4, a half of 4 is 2. So now we're out here. So if you notice, my graph is getting wider, so that is known as a vertical shrink, because when you divide by 2, it makes those numbers smaller. So now that means my original horizontally is getting stretched out, okay? It's getting stretched out. So vertical shrink and horizontal stretch is the same. Vertical shrink and vertical stretch and horizontal shrink is the same. All right. Compare the graph of each of these, okay? So if we're looking at this, we have f of x equals the absolute value of x. So that's kind of our V-shaped. That's our V-shaped graph. Okay. Now, my C is 3. So when I multiply by 3, my numbers are getting larger. So that would be a vertical stretch. Okay. And now, since it's a vertical stretch, it's actually a horizontal shrink. Okay, so that means that graph is going to be more narrow. Okay. All right, now we're multiplying by 1/3. Okay, my C is 1/3. Now, when you multiply by 1/3, your numbers are getting smaller. So that would be a vertical shrink. And so since my numbers are getting smaller, it's actually a horizontal stretch because now it's getting wider along the y-axis, or the x-axis, excuse me. All right, example 5. Compare the graph of each function with the graph of f of x equals 2 minus x cubed. Okay, so we're evaluating f of 2x. That means we're going to evaluate when x is equal to 2x. Okay, so f of x, so actually it would be g of x, sorry. G of x will equal 2 minus, what is replacing my x? This 2x. Okay, so g of x will equal 2 minus 2x cubed would be 8x cubed. Okay, so now as we look at that, I'm going to rewrite this as negative 8x cubed plus 2. So let's go ahead and compare the graph. Okay, the negative in the front tells me it's going to be a reflection over the x-axis. The negative 8 tells me we're going to have a vertical stretch. And if I have a vertical stretch, I'm going to have a horizontal shrink. And then this plus 2 tells me I'm going to go up 2 units. And then part B here. All right, h of x equals 1/4 of x. Okay, we have h of x will equal 2 minus 1/4 x cubed. Okay, so 4 cubed is 64. So I'm going to write it as 1/64 x cubed. And then rewrite as negative 1 over 64 x cubed plus 2. So the only thing that is changing from part A to part B, that should be a cube too, is my A. Okay, my A is that 1 over 64. Okay, so instead of a vertical stretch, we have a vertical shrink. And since we have a vertical shrink, we actually have a horizontal stretch. And that's all the transformations you need to know. Okay? If you have questions, please let me know.